All right, so here we're on 13.2 on applications in business and economics. So we're going to look at the probability density function, continuous income stream, future value of a continuous income stream, and consumers and producers surplus. So first, the probability density function. So we're going to take a brief informal look at the use of definite integrals to determine probabilities. Now, a more formal treatment of the subject requires use of special improper integrals from going from negative infinity to positive infinity of f of x dx, and we're not going to discuss that. But we're going to look at an experiment where it's designed such a real number x on the interval from c to d is a possible outcome. So, for example, X may represent an IQ score, the height of a person in inches, the life of a light bulb in hours, or whatever. And technically, we refer to X as a continuous random variable. So in certain situations, we can find a function f with x as an independent variable such that the function f can be used to determine the probability of x from c to d. Basically, it's in the interval from c to d. That is, the probability that outcome of x of an experiment will be in the interval c comma d. Well, it includes C and it includes D. Now, such a function is called a probability density function, and it has to satisfy the following three conditions, and we'll see the figure on the next slide. So f of x has to be greater than or equal to 0 for all real x. The area under the graph of f of x over the interval from negative infinity to positive infinity is exactly 1. And if c interval c to d is a subinterval of that, then the probability of that interval over the interval is the interval, integral from c to d of f of x dx. And so what we're saying here is this is the whole f of x, and it's going to be greater than 0, and the area under that whole thing is going to be equal to 1. But what we're looking at is we're looking at a chunk of it from just C to D, and it includes C and it includes D. And we're saying that the probability that it's in here is going to be the integral from C to D of f of x dx. So our first problem, so it says, in example one, find the probability that a call selected at random will last 4 minutes or less, and then find B to 2 decimal places. So the probability of a call selected at random lasting B minutes or less is 0.9. All right, so what we need to do is we need to first plug in on A, we need to plug in our variables. Well, we're going from 4 down to 0, basically. So we're going to use this part of the function, okay? And so basically our A is going to be the integral from 0 to 4 of 1/4 e to the minus t over 4. And then we have our dt, of course. And that 4 doesn't look very good. Okay. And so what we're going to do is we're going to let u equal a negative t over 4, and du then is negative 1/4 du. Well, here we have a negative 1/4, so all we have to do is put a negative out in front. And so that's going to give us a negative integral e to the u du. And after we take that integral, we're just going to get, I'm going to go down here because we're going to run out of space probably. We're going to have a negative e to the u, because the integral of e to the u is u. And we put our u back in here, t over 4. And we're going from 0 to 4. All right, so that's going to be equal to what? Well, negative e to the minus 4 over 4, and then minus negative e, and it's going to be to the 0, basically. So this is going to be plus 1, and this is going to be negative e to the negative 1. And typing all that into our calculator, I'll do that by hand. It's going to give us a negative e to the negative 1 minus, or actually minus a minus 1. And so we get, it looks like 0.6321, and we'll probably round that to 2 decimal or 3 decimal places, 0.632. That's what we'll do. Okay. So that's going to be the probability the call selected at random will last 4 minutes or less. Now, the next one says now we're supposed to go up to B. So instead of 0 to 4, we're going 0 to B. And we want this to be 0.9. So this would be, we'd come up with our answer, but now we know the answer. And what we're going to have to search for is this B. And so we put our equation or our function back in. That's 1/4 e to the minus t over 4 dt. We're going to do the same thing. We're going to take that integral. And when we do that, guess what? We're going to get basically this here piece. So we're going to get 0.9 equals, and we're going to get a negative e to the negative t over 4 from 0, oops, not to 4, but to b. Okay. And now what we do is we plug in our b, so then we get a 0.9 equals e to a negative e rather to the negative b over 4, and then we're going to have minus, and then we're going to have negative e to the 0. All right. Well, that's plus 1, so if we subtract 1 from both sides, now we get, well, that's going to be what? A negative 0.1 equals a negative e to the negative b over 4. Well, that negative cancels that, so you can either divide by 1, or we can just say, well, that negative cancels that negative, and we're positive now. And then we need to solve for this b, so now I need to take the ln of both sides. And now since it's positive, we can do that. And when we do that, remember the whole exponent comes down in front. So we're going to have then, let's go up here now, ln of 0.1 equals a negative b over 4. And then we have ln of e. ln of e is just 1, so we just have a negative b over 4. Now we want to solve for b, so if we multiply by a negative 4 and we multiply this by a negative 4, we get b is equal to, and now we just have to take negative 4 times ln of 0.1, and it looks like we get 9.2103, and they only wanted two decimal places, so that's about 9.21, and that's going to be minutes. All right. So this case, we had to solve down and figure out what our minutes were, our probability was rather. And we got here. Here they gave us a probability, and we had to find our upper limit on this, and we found that it was 9.21 minutes. All right, let's stop there. We'll come back for some more.